All right, so today we are going to add an additional step to factoring. It's good because you can practice what you've done with just one more additional step.
Why would you have steps if you know all the steps?
You don't.
It's like, hey, let's bake a cake. Let's
Well, it's like icing it. Well, it's like actually preheating the oven.
It's like already. Exactly. Let's just get
What
a
if you
pre-made
just buy a
cake.
pre-made cake?
Let's just buy a pre-made cake.
That's
We
a
should
calculator.
in class to put like +2 or bonded that says like.
Let's make a goal of learning some material. All right. So a lot of times when we factor, the polynomial was almost prime, meaning you only had to do one step to factor it. But the reality is it might be a two-step factoring process. And one step is factoring out the GCF first. And the first thing we learned about in this chapter is factoring out the greatest common factor. That's what GCF stands for, is greatest common factor. So when this says factoring completely, it means the greatest common factor has been factored out, and then we can factor the remaining trinomial, and we're going to use the snowflake to do that. Okay, so who can tell me what the greatest common factor is for this trinomial? DJ? Does everything have an X?
No.
Yes. And if your lead term is negative, it's generally easier to take out a negative GCF. So the GCF, I'm going to say, is -6. And then it makes your trinomial have a positive x squared term, which is preferable. So if I take out a -6, -6 times what, Twinkle, is -36x squared. 6x squared, good. And then Ashley, what would my next term be? And then Maggie, my last term? Okay, good. And so I did the first step, which is factor any GCF out first. So the greatest common factor could have been 6. It also could have been -6. But I always, if this is negative, my lead term, I always like to take out a negative. So it leaves a nice positive trinomial remaining. And so now I'm going to factor this. All right, and I'm going to factor that using the snowflake. So, Charlize, I know you just got back, but what goes at the top of the snowflake? What's that?
I don't know.
Okay, DJ?
Negative, no, yeah. Negative. I'm not so sure how to do that off the top of my head.
The top of the snowflake?
Isn't that, oh, wait. Here.
Okay, we're factoring this.
Oh, that?
Yeah.
Okay.
So what goes at the top of the snowflake?
-12.
Good. And DJ, what goes at the bottom?
1.
And what goes on top of the horizontal line?
6.
6. All right. So one of the things that make factoring out the GCF good, other than the snowflake wouldn't work if you didn't do this, so you have to, but it makes the numbers smaller. So DJ was struggling because he was trying to multiply -36 times 12 in his head, so now I understand why you were pausing here. But 6 times negative 2, we're only factoring the thing that I underlined there. Maybe I'll highlight it too so we can, this is what we're factoring, and that's what we're putting inside of here. So now, Davion, we're thinking of two things that multiply, give us negative 12, and add them to 1.
Negative. Negative 3 and 5.
So they have to multiply to negative 12. Oh, you want to write them out? One hint is 1 is going to be 4. 4 negative 3, good job. So 4 times negative 3 is negative 12, and 4 plus negative 3 is 1. And then, Brendan, I need to reduce these, which look like fractions, but they're actually not. But what is 6/4 reduced to?
1.5.
How about is an improper fraction?
Oh, sorry, 3. 0/2.
Okay. And how about the other one?
2/1.
Okay. And Amelia, how would those be as factors? Yeah, but just focus on the snowflake here.
Oh, okay.
Okay, Ava, what would the factors be?
3x plus 2 and 2x minus 1.
Okay, good. So this 3 and the 2 gives us this 3 and this 2. And then this 2 and negative 1 gives us this 2 and this negative 1. All right? And so now what Amelia was asking about was what about the negative 6? Okay? So negative 6 just stayed right here, and then we factored what was on the inside of the parentheses. So our final answer, let me show you how we write it. We write it as negative 6 times 3x plus 2 times 2x minus 1. And that is our final answer. That is our factored answer. In other words, that is what the original problem equals. Negative 6 times 3x plus 2 times 2x minus 1. Because if I multiplied all that out, I would get what I originally started with. I need the negative 6 as part of the original factorization. All right, questions on that? Denise, what's the GCF that I can take out? One. Let me give you a hint. It's a variable.
Oh, x squared.
X squared. So if I take out x squared, can you tell me, Navneet, what polynomial would be left if I take an x squared out of each term?
Y. Squared.
Yeah, and then what?
And then 2x. Or no, just 2, sorry. 2y.
Y, yep.
And then negative 6.
Good. All right. So I factored out the x squared because it was what I had in common with every single factor. Now I'm going to see if I can factor the remaining trinomial. That's the thing I have on the inside of the parentheses. So I'm going to factor this. So I'm going to snowflake it out. So Isaac, can you help me set up my snowflake?
So negative 15 again on the top, and
bottom and then one on the sides. Outside.
Goes what?
One.
Once. Okay, so Talisa, two numbers that add up to negative 15, sorry, multiply to negative 15, add up to negative 2. 5. Now you want the 2 to be negative. Negative 5 and 3. Good. Because negative 5 times 3 gives us the negative 15. Negative 5 plus 3 gives us the negative 2. Now, these are already reduced. Okay. So, Brennan, can you name the factors for me?
It'd be x plus negative 5 and x plus 3.
Okay, and I just changed the variable to a y for you.
Oh, yeah.
You had the numbers correct. All right, and now when we write our final answer, we write what we took out, our GCF, which is x squared times y plus negative 5, or you could write y minus 5 times y plus 3. And if I were to multiply all that together, I would get what I started with. Not me?
Do you have to put in like your final answer with the GCF, or can you just leave it?
You have to include it, because if you multiply this out, there's going to be no x's in it. And what you get when you multiply it all out has to equal what the problem was originally. They have to be equivalent when you multiply them all out. And so if I only have y's here, my answers won't be equal. That's a great question. So Isabel, is there anything I can take out?
Yeah,
5, okay. And what do I get when I take a 5 out?
5 times x squared minus 3x minus.
Okay, questions on this?
What?
So not all the terms have x's. So it's called the GCF because C means common. So all the terms have to have it. That's a good question. Talisa?
So if you had x and then put x on
If the 50 had an x, yes, you would have 5x as your GCF. Okay, now I'm going to factor that. All right. Twinkle, can you help me set up my factorization, my snowflake? Okay, what goes at the top? Okay, at the bottom. Okay, and above the horizontal line? Good. All right, Ashley, two numbers that multiply to give you negative 10 add up to negative 3. 2 and negative 5. So 2 times negative 5 is negative 10, and you add them up, and you get negative 3. Right? And then, if I set up my factors, that is 1x plus 2 and 1x minus 5. All right. And then you can either just bring down that 5, or you can rewrite the whole thing. Right there. Question. Okay, so be careful, okay? This skill, it just transcends. Like, we do it in Calculus 3, we do it, like, you never stop factoring. It's not one of those that I can say, okay, it's okay, you don't get this right now. It's not. You can't leave algebra unless you know how to factor. One of those gateway skills. have a great rest of your Monday.